Okay, this is our functions trig quiz review, chapter 5.1 and 5.2. Let's look at problem number 1. It asks, what quadrant is 307 degrees in? Well, remember, negative is in this clockwise direction. There's negative 90, negative 180, negative 270. And then from negative 270, let me go another 37 degrees, and boom, there I am, negative 307 degrees, definitely in quadrant 1. Okay, so problem number 2, it's asking for a coterminal angle. All right, and it wants to be positive and less than 360. So in this case, my first coterminal angle that's positive is 127 plus 360 equals 233. Let's think a little bit again what coterminal means. This first angle I drew, if I go negative 90 and then 37 more degrees, then this angle here then is negative 127 degrees. All right, now if I go this way, there's 90, 180, plus another 53 degrees, and that is a positive 233 degrees. Okay, so just remember what coterminal means. This guy and this guy, when I draw them, I get an angle that's in the exact same position. Okay, arc length formula. Arc length is equal to the central angle times the radius. This only works when theta is in radians. Okay, so they give me the arc length, they give me the radius. So if I solve this equation, my answer then has to be in radians. Okay, number 4 is a simple conversion, negative 60 degrees, and convert that to radians. And this is no surprise. We should know that when we chop up our circle into 1/8 pieces, that a 60-degree rotation is the same thing as pi over 3, and we're just going negative. And if you remember that, then you don't have to go through all this tedious stuff. Either way works. Question number 5, going backwards, okay? I have 5 pi over 12 radians, convert that to degrees. Remember, this is all ratios of a circle. So this many radians as to 2 pi is how many degrees at 360. Cross multiply, clear the fraction, blah, 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 whatever you want to do. What did I do here? I cleared the fraction. Multiply both sides by 360, reduce, divide, 150 degrees. Also, by the same token, you can see that 5/12 is just a, do I want to go there with this? No. All right. We could also calculate or think of, well, I have got 5 pi over 6s? No. Yeah. I got 5 1/6 rotations, and a 1/6 rotation is 30 degrees. So 5 30-degree rotations also give me 150. So that's another way you can think about it. Okay, now this problem here, a lot of students made a mistake, and they plugged in 150 degrees into the arc length formula, and that's not going to work. This thing, theta, the central angle, must be in degrees. So we need to convert 150 into pi over 6, or no, that is 5 1/6 rotations. Or we just got through calculating it right here. All right, so once this is in radians, we can throw it in our formula, and we're good to go. Number 7 and number 14, we are going to go in way more detail, especially in number 14 in later on work that we're going to do. So we're going to skip that for now. Your cofunction formulas. We reference this in the page of the book rather than try to memorize them all. And we know our cofunction formula for tangent is the cotangent function. And literally, we just plug and chug. Tangent of 77 degrees is equal to cotangent of 13 degrees. Okay, calculator exercises. Make sure your calculator is in degrees. Before you enter this, hit enter, good to go. That's the ratio for 77 degrees. Sine of 88 degrees. Again, make sure your calculator is in degrees. Just plug this in, and that's the opposite over hypotenuse ratio for 88 degrees. Okay, cosecant. There's no such thing as a cosecant on your button, but we know that, button on your calculator, but we know that that is the inverse of the sine. So once we have the sine, we just take the inverse of that number, and there's our answer. Oh, that is a ratio, not degrees. My bad. Here, arc sine. So here I have a ratio of adjacent over a hypotenuse. That happens to equal this decimal. So I take the arc cosine. Again, make sure your calculator's in degrees. And it's going to spit out my answer in degrees. How are we doing on time? Let's continue this in another video.